This third topic deals with the main actors. Control the geomorphological dynamics of coastal areas, very particularly on the beaches. We have divided it into two parts. In this first part, we will focus on the contents that we have highlighted in bold. Waves are the main agents modeling coastlines. So it will be key that we know how they originate, what features have, and how they move and evolve. The origin of the great majority of the waves is the wind, and only a few have a different origin, as tsunamis that occur by sudden alterations in the ocean floor and originate by earthquakes. Here we will focus on the most common waves, those originating from the transfer of energy from the wind to the waves. How much energy the wind brings to the waves depends on three factors: the distance the wind is blowing and over the seawater, which is what we know under the name fetch, the time during which it is blowing, and the speed with which it does so. The fetch, for its part, depends on the disposition of the masses of waters and land over the great oceans. The wind can being blowing and providing energy over very large distances, thousands of kilometers, while in enclosed seas or bays these distances they are much shorter, so the geography itself already determines the potentiality of higher or lower energy waves. So if you want to know in more detail how it is transferred, energy from the wind to the waves, or its genius, I suggest you see the video that I show you here. On the other hand, it is important to note that the wind is what defines the direction of advance of the waves, at least as long as we're in what we know as the deep waters. The waves can be characterized by different parameters. The most important are the wavelength, which is the distance in meters between two sinuses or consecutive ridges at this distance, and the wave period, which is the time in seconds it takes to get through the same place two ridges of successive waves. Both wavelength and period parameters are directly related depending on the speed or celerity with which the waves move. And the third parameter, that S key, is wave height. It is the distance in meters that there is between the trough and the crest of the wave. It is this distance, and in the attached video you can to deepen these aspects. The wavelength is going to remain stable as long as we are in deep water. We define as deep waters those in which the depth is greater than half the wavelength. In this area, the waves do not move mass, but only displace the move in the direction it's been driven by the wind. That movement of water not only glides across the sea, but it also moves into the depths. Water particles follow a rotational movement that moves down so every time, but it's getting weaker and weaker, and there comes a time when it disappears. Therefore, the effect of the waves is very important in surface waters, but it is decreasing until it is annulled as the depth increases. What happens when the waves reach the coast? When it reaches a depth of less than half the wavelength, rotational downward movement hits the bottom, feels it, and this friction causes the advance to be stopped, causing the waves to get shorter. While their advance continues as compensation, the wave is leaving, making progressively higher. The whole process is exaggerated until a moment arrives in which the wave becomes unbalanced and breaks, displacing at that moment a water mass forward in the direction of wave advance. You can see a slightly broader explanation of the changes from the wave in the two videos shown here. And with this we end this first part of the topic on the agents that explain the coastal geomorphological dynamics.